Exponent laws, the quotient rule. Step 1. When dividing powers with the same base, subtract the exponents. Step 2. If the coefficients are not 1, but something else, divide the coefficients. So here is the property. We have a quotient, x to the power of a divided by x to the power of b. You then subtract the a, subtract b. So let's look at example 1 here. 4 to the power of 6 divided by 4 to the power of 2. The base is the same. So 4 and 4. So we're going to rewrite it. Simplify the expression as 4 to the power of 6 minus 2, which is equal to 4 to the power of 4, which is equal to 256 if you're asked to evaluate it as well. If the coefficient is 1, for example, we have variables, hence the coefficient is 1, we're going to add the exponents here. So m is one variable, or one base. Then we have n to the power of 6, n to the power of 3. So m to the power of 5 plus 2, and n to the power of 6 plus 3. Now, if the coefficient is something other than 1, you're going to also divide the coefficients. So we have here the first coefficient is negative 4 and 2. And then x's and x's is the next base, and the y's. So negative 4 divided by 2. Then x to the power of 2 minus imaginary 1. And y to the power of 4 minus 2, which is further simplified to 4 divided by 2 is negative 2. X to the power of 1, we don't have to write it, it's an invisible exponent, and y to the power of 2. So we're going to look at some examples. Simplify the following exponential expressions applying the exponent rules, then evaluate if possible. So for question A, we have one base, 3. So because this is a division, a quotient, we're going to subtract the exponents. So 3 to the power of 6 minus 2, which is equal to 3 to the power of 4. B, we have the same base, 5 and 5 in both. So we will rewrite the base and subtract the exponents. Therefore, it equals to 5 to the power of 1, which you can just write 5. Question C, we have again the same base, 9 and 9. Therefore, the base 9 to the power of 7 subtract 4 is equal to 9 to the power of 3, which is equal to 729 when evaluated. And I just noticed for 2a, since we do have to evaluate it, as the question asks, 3 to the power of 4 is equal to 81. So let's look at example D. We have two variables, m and n, and the sign is division. Therefore, it is m to the power of 7 minus 5, and n to the power of 8 minus 3, which is equal to m to the power of 2 and m to the power of 5. And now we'll look at example E. We have two coefficients here, negative 6 and 2, x's and y's. So negative 6 divided by 2, x to the power of 10 minus 7, y to the power of 9 minus 2 is equal to negative 3 x to the power of 3 and y to the power of 7. Looking at example F, we have negative 3 and 4 as the coefficients, x's and then y's. So negative 3 divided by 4, x to the power of 2 minus 1, y to the power of 7 minus 2 is equal to negative 3 over 4, x and y to the power of 5. Question G asks us to find the missing value. So we know that we are working with same bases, and here's a quotient. So 8 to the power of 5 divided by what base to the power of 2? That will give us 512 when evaluated. So if it is 8 to the power of 5 minus 2, it will equal to 8 to the power of 3. And let's see if 8 to the power of 3 is equal to 512. It is. Therefore, the missing value is the base 8. Looking at example H, find the missing value again. So we have division, a quotient, and we have two variables, m and n. So we're going to look and examine at the m's, since that is the one that we're missing. So we do know that a number here, subtract, I'll give that value an x, minus 3 will give me this value, 2. Therefore, x, if I bring the negative 3 over to the other side, becomes positive. So 2 plus 3, therefore x is 5. Finally, I find the missing value. So we're trying to find the value of the exponent of x. So we'll take a look and compare the x's. So we have x7, and our final answer should be x to the power of 1. So again, I'll give this value we're looking for, instead of it being x this time, maybe I'll make it a. So we know that 7 minus a is going to give me 1. Therefore, 7 is equal to, or 7 minus 1 is equal to, I'll move the a over, is equal to a, which is 6. Therefore, my final value is 6.